Hello, and thank you for joining me. We're going to be looking at, in this video, classes, Python classes, and object-oriented programming. We're going to try to solve the challenge of taking everyday objects and items in the physical world and trying to structure them in such a way that a computer can understand and easy for us to program. So what we're going to do is we're going to start off by thinking about an object. And for this object, let's say it's a dog. And a dog has certain characteristics, such as gender, breed, age, hair color, temperament, temperament, okay, temperament. There we go. And we might also say that it has certain behaviors or actions. Characteristics, by the way, we might also say as attributes. And the reason is that we're going to come back a little bit later on with those. And so we're going to be referring to them later on as attributes. So we might as well just start now. And for the actions, we might think of actions, behaviors, or as we'll call them in programming, methods. These are just the things that the dog can do. So, for instance, a dog might be able to, my dog might be able to bark, might be able to sit, walk, eat. Some dogs might be able to um, sit on command. Some might come on command. These are things that, as coders, we might have to account for. And so, how can we help computers understand these subtleties and nuances between one dog and another dog? Well, let's start by actually going and trying to code a dog's action. All right. So up until this point, we'll start by trying to code one action. And up until this point, we've been working with what's called a procedural or a functional way of writing programs, in that we create functions that handle our various tasks. So let's do that. Let's define bark, or actually, we'll do bark. And that we might say print bark. And if we run bark, the dog will bark. So this is what we've been doing so far, is using functions to organize our code, in especially here with barking. So, all right, well, that handles that. We could have a defined sit, walk, eat, whatever. That doesn't handle the coding a dog's attributes. So what about its characteristics or its qualities? Well, all dogs can bark. Maybe they sound differently, or have a different bark. And in that case, we would maybe have to code in bark low, bark high, bark loud, bark soft, whimper. We might have to code in all these different things that each individual dog can do. But what about attributes? So let's start off with just gender. We'll just say it's a male. We can do breed. If you're a cat person, you can feel free to swap these out for a dog or a cat or any animal. It doesn't really matter for today's video, or this video. We might say it's a Great Dane, and we'll give it an age of 13. So that's one way we could do it. And this works initially, and especially if we have a short program and only one dog. The second we have more than one dog, this becomes increasingly more difficult, where we might have to have gender 1 equals male, or gender 2, or maybe that's a name. So we could have, you know, uh, dog name's Ghost, right? So Ghost gender. All right, we have to do something like this. Oh, come back now. There we go. So we have to do something like this, where we have to um, add in new variables. Oh no, what's happening here? We have to have new variables for each dog and append it with like Ghost name, which doesn't make any sense because Ghost is the name. So Yeah, either that or we do dog one name, dog one gender. This is no good. This is a lot of work. So this is option one. I'm gonna put that up here. Option one is variables. And that's not a very good option, to be honest with you. Option two is something we've seen before, which is dictionary. Okay, well, why couldn't we create a dog object, maybe dog one equals, and then pass in its um, characteristics? It's gender, male, breed, Great Dane, age, 13. And then we can access the properties by saying something like print dog one, age, dog one, gender. Oh, I'm going to comment these ones out up here. I remember you can highlight stuff and do highlight lines and do control / and it will, at least in this editor, you can do that. Okay, so we find out we print dog one's age, and we find that dog's 13. Okay, so here we have um, our attributes, and we have our actions. And we assume that every dog um, can bark. But what if some can sit and some cannot? We can code in a define sit. I am sitting, or something like that. But how do we know if a dog can sit or not? Maybe we do an if-else statement before that, or maybe do an if-else statement inside of here. There's a lot of different ways we could check to see if a dog can sit or not. But this runs into another problem. Okay, this works for dog one. Um, maybe here we also maybe do like a name. There we go. So you have a name, gender, breed, age. So this works well for dog one, but if we want to say that dog one can walk and dog two cannot, right? We have to do the same thing. We just copy this and put it down here and label the next one dog two. How can we do a check for that? Is there a better way to organize this code rather than global functions? And yes, there is a third way of organizing code, and that's option three, and that's what's called classes or object oriented programming, abbreviated OOP. So, what is object oriented programming? It's a way of thinking about programming that goes beyond variables and dictionaries, lists, variables like up here, and functions, meaning global or local functions, functions within functions. It goes beyond the way of organizing code into functions, and we instead organize our code into objects. Objects look slightly different, but they serve a really practical purpose in that it probably looks confusing when we look at objects. We're going to take a look at them in a second. Probably looks really confusing when we look at objects, but actually, a lot of people find object-oriented programming to be a lot easier than variable and functional or procedural programming. And that is because we could take objects that exist in the real world, the physical world, and we create essentially a template of that object, a prototype, that we can then make copies of for each individual case. So we're going to walk through in the next couple of minutes how we can do that with a dog or dogs. And let's start by first going through and creating a class. Okay, so what is a class again? A class is just a blueprint or a template, something that can be copied that will have the same structure, um, properties, methods, or functions built all inside of it. It's going to have the same structure just over and over again. We can think of this as like a dog. A dog, all dogs have roughly the same shape. They all have certain characteristics: tails, ears, walk on all fours. Um, some are hairy, some are different colors and different hairs. So there's some minor subtleties, but we can think of a class as like a classification, like you would do something in the animal kingdom, or a class of a car. There's trucks and sedans and motorcycles. Does every motorcycle look the same? Absolutely not. But they're all motorcycles and they all have similar characteristics, right? We can classify something as a motorcycle. So we can do the same thing here. We can do class dog. Okay, so how do we set this up? Well, we use the keyword class. This is a Python keyword that's built into the engine. We capitalize the class name with dog. Inside the brackets here, we write the word object. And what that's going to do is it's going to actually go and is the serves as the base class of the hierarchy. So when a class is created, it accepts no arguments inside of the parameter. We don't pass anything in directly inside that. But essentially, we're telling Python that this class dog is going to inherit all the different object properties that the template's going to give it. Okay, so I'm going to create a. Oh, we got to create a put our colon there. Don't forget that. I'm going to put a comment and say a virtual dog. All right, and first up, let's actually give this virtual dog something it can do. So I'm going to give it. We're going to define a function inside of this class dog, and we're going to have it say hello. Print hello. I am new here. All right. Inside our say hello definition, inside the parentheses, we have to put something. We have to put the word self. And I'm going to explain why in just 1 second here. Okay, so this is an instance of a dog. I am new here. And let's create our first dog. So it's as easy as going down and we set up a variable, a name of a dog. We can do dog1, or if you want to put a name, you can do that. Dog1 equals dog. Okay. Dog1 equals dog. So this dog, first dog is going to equal this dog object, just a copy of it. Okay, this is how we create a copy. And then what we can do is say hello is a function that's built into a dog. It's an action a dog can take. And how do we access that? Is we can just do dog1 dot say hello. We put parentheses there. We run it. We have the dog1 say hello. It says, hello, I am new here. Okay. So we've created a copy of a dog and we got it to say hello. We can do another one. We can do, let's say, define bark. We pass in the self parameter, print bark or a wolf, something like that. Fine. And if we want to make the dog bark, we go down here, we say dog1 bark. Then we run it, we see that the dog woofs. So this is how we can create objects in the real world or translate objects in the real world into a language that computers can understand. So let's talk about this self word here, the self parameter. So what is it? Why do we need to use it? The self parameter is goes inside of a class and is put inside the parameter for the functions. And functions inside of a class we call methods. Methods are just functions that are inside of an object inside of a class. Okay. This function only has one parameter. It is the self. It doesn't actually use self anywhere inside here, so it's not like we use self. Hello, I am new here. Self. The parameter self provides a way for the method here, the say hello, to refer to this object itself. And basically, this self is going to tie this method to this class dog. We're going to see it used in later on, and where we're going to actually assign parameters to this dog using or assigning attributes to the dog using self. But for right now, we just need to enter it as part of just the standard language of building functions inside of a class object. Okay, so that's the first part. That's very good. What I'm going to do is I'm going to get rid of the dog1 say hello, dog1 bark. Okay. And so right now we still have the class dog, and as of right now, this still exists. What I'm going to do is I'm going to copy this down here. So I make 2 copies of it. But I'm going to comment out the first one. And the reason for that is we're going to make a modification. So I want you to be able to see both of them. We can compare. And right before the second copy, I'm going to make a little comment here that is adding a constructor. All right. So a constructor has the role of as soon as a class object is copied, okay, we did that when we said dog1 equals dog, we can set up functions to happen immediately after it's copied. And that happens in what's called the constructor. All right, so let's take a look at what that looks like. So inside of our class dog, a virtual dog, um, I'm going to go to right below a virtual dog and right above say hello. And I'm going to define a new function. This one I'm going to put 2 underscores. So on my keyboard, it's right next to the 0 button. If you just press the button, it will do dashes. If you hold down Shift on my keyboard, it will do underscores. So we need 2 underscores, and then we do init, and then 2 more underscores. We pass in self, and you can put a colon at the end. So what is this doing? What is with the double underscore there? Whenever time you see a double underscore inside of Python, it's actually referring to the a special method, a special function that's built into Python itself. It knows what these are and knows what to do with them. So we init, and this is called the constructor. This will run as soon as the copy is made. And so what we can do is we can say say hello, I am new here. We can say print, I am a new dog. So let's go down here below. I'm going to backspace out to make sure I'm in the main line of the program. And we can do dog1 equals dog. And I'm going to clear out the console here by hitting that little X button. And I want you to show you this because we've created a new dog, right? We made a copy of the dog class. New dog's called dog1, not very exciting. But here we have a constructor built in. So now we click run. Notice that we didn't say, dog1 dot, and we didn't do that, right? We didn't call on it. It just ran. And so that's what the constructor does. It's going to set up your functions to run as soon as the copy is made. And this is going to be handy for setting up like properties or attributes or customizations to the dog as soon as it's created. Okay. If we want to create multiple instances of a dog, we can do that too. We can do dog2 equals dog, dog3 equals dog. So we can create as many dogs as we want. Dog4 equals dog. I'm a new dog. These are all dogs. And we can do dog3 bark, and dog3 can bark. Can dog2 bark? Okay, so dog2 barks. Every dog can bark because we've created a class, and all we're doing is making copies of it when we do this. And when a copy is made, it inherits everything that's in here already. So what's really neat is that if we want to do a new function, let's say sit self print I am sitting. What's neat is that all the dogs now inherit the sit ability. So if we want to do dog3 sit, the dog3 can now sit. We just taught it to sit just by adding it in the class object. And this is a heck of a lot easier than going up and like we had with the dictionary and maybe listing off what functions the dog can do or abilities the dog can do and then tying them to a function. Here we've added basically, we haven't talked about prop attributes yet, but essentially we've added the ability to add functions, custom functions that are contained to the object that we don't have to worry about passing in parameters or calling on these functions. They're built in. So all I have to do is say dog3 sit. We've seen this before with things like turtle, where when we include turtle in our programs, what essentially we're doing is we're going to the turtle object, the turtle class, and asking it to bring out certain things. Forward, um, go to, all these things are built in methods that the turtle knows how to do, and we're just accessing that. And so that's we do the same thing here. We're just building um, our own class object. Okay, so that's how we add in classes. That's how we can instantiate classes to build classes. We'll talk about in the next video is how we can add in what are called attributes. And attributes are simply just properties of that dog, uh, properties of, or yeah, properties or characteristics of that dog that we can then go and um, define and make individual to each dog. So I asked at the beginning, how would you know if a dog could sit or couldn't sit? One of the things we can do is we can define properties, can sit, for instance, and we can set that to be a Boolean, true or false, and we can do a check inside the program. If true, we can have the dog sit. Basically, it can check. Basically, the dog's going to check itself to see if it can sit before it will sit. And so we can build in those things right into the class to ensure that our program is working exactly how we intended and that our class objects are not doing anything that they shouldn't be doing. But this is a very, very effective, easy way to code out objects very easily. And a lot of people actually prefer this. Is actually considered to be a more advanced um, concept to learn in programming is object-oriented programming. But it is a lot of people actually find it a bit easier because all you have to do is think of the world around you and think about the properties, the characteristics of those objects, and what they can do, what you might want them to do. And then all you have to do is basically build out the functions as a part of it. So if you're in web design, forms, it's like submission forms can be built this way. We code, like I said, we can code websites this way. Games are coded this way in class objects. It's very, very popular. Where you build out instances of an object, and an object can have something like a an image attached to it that is specific to that object. So this is a very important way if you're going to go into programming or learn more. It's something that you're going to counter and have to become familiar with because you're going to see a lot of it out there um, in the wild. So that's it for this one. Thanks for watching. I'll see you in the next one.